Data classes are old news. They've been around since Python 3.7, which was released almost 3 years ago, but this doesn't mean that everybody knows or let alone uses them. Let me know in the comments if you have used data classes before in your projects. So, what are Python data classes and should you use them? Data classes are just regular classes that are geared towards storing state rather than containing a lot of logic. Every time you create a class that mostly consists of attributes, you make a data class. What the dataclasses module does is make it easier to create data classes. It takes care of a lot of boilerplate for you, and we know that boilerplate code is bad. Creating a class for holding data and implementing the functions supporting them is not the hardest thing in the world, but there are downsides to them. If you had to add a new field, for example, you have to modify all the functions around them, and your time is worth more than that just fiddling with code that could be generalized and hidden away from the developer. Here is an example. Let's say you have a web shop and you want to represent the items available on the page. An item will have an ID, a name, and the available amount in stock. When you have fetched them from the database, you could place them into a name tuple. But as time goes on, you realize this is not the best way to handle it and create an item class to hold these. Now it is much cleaner and easier to maintain. Or is it? Let's add Ripper, so that we can log them, for example. Fair enough, add support for comparison, implement dunder equal and dunder not equal. You will probably put the instances into a collection. You want to use a dictionary for this. Now you will need a hash function, so the objects are hashable. On top of this, you might want to make your object immutable, or make them sortable, and so on. This is a lot of boilerplate code already. The customer asks you to add the ability to select colors, and you will realize that now you have to change a whole bunch of code in your implementation. You will need to create tests as the class grows, because you don't want to miss anything when you modify this much logic. Tests are not bad, and you should create tests, but you could have avoided them in this case if you've used data classes. Add the data class annotation to your class. Set some parameters. Add your attributes with type hints, and you are done. This is a basic example, and it is the bare minimum you need to get started. The first thing you might notice is that you can skip the dunder init function entirely. It is because data class will handle that for you. If you want to do something during initialization, you can implement the dunder post init function. There is also more customization on the data class annotation that you can do. You can turn on and off features like the generation of the init, Ripper, equality, and order functions. You can make immutable classes by setting the frozen parameter to true. It will raise a type error if you try to mutate the class. You can define a default value for your variables by giving them a value. Using mutable objects as default values like this is a big no-no, just like when used in parameters. You need to use the field function from the dataclasses module and set the default factory in case you want to have a mutable object as a default value for a variable. You need to provide a function which will be called with 0 arguments and returns the value you want to set as default. It can also be used to further customize the fields. The init parameter can be set to false to omit the field from the constructor's parameter list. Similarly, Ripper, compare, and the bash boolean parameters can be set to false in case you want to leave these functions with one exception. The hash parameter can be none, which is the default value. In this case, it will use the compare parameter's value, and this is the expected behavior. You can set it to false to skip the hash computation if it is expensive, for example. The last thing about fields is there are class variables which are excluded from consideration as a field and is ignored by the data class mechanisms. There are init-only variables which are added as parameters to the generated init method and are passed to the optional post-init method. They are not otherwise used by data classes. If you ever need to convert your classes to dict or tuple, you can do that too with the asDict and astuple methods from the dataclasses module. This is useful if you want to serialize your classes, for example, but there are better methods to do that. So, should you use data classes in your projects? if you've watched the video up to this point, then you could decide it by yourself. But if you just want to hear my take on it, then it is fine as well. I think that every feature that saves time and are part of the standard library are good and should be used. After all, programming language is a tool and it is only there to help you finish your work or hobby project, so you can move on to monetizing or using it. As you could see, this feature is so simple and saves you tremendous amounts of time and lines of code by making your program more fail-safe and less error-prone with a smooth learning curve. Just like most features in Python, it is a no-brainer that you should definitely use it. So, that's my take on data classes and why you should use them. I hope that you can incorporate it in your projects from now on and see the benefits for yourself too. If you liked the video, press the like button. If you didn't like it, press dislike, subscribe and have a good one.